Now we're ready to roll. So, today's notes is all about momentum. The first half, you'll see that there's kind of two sections in our notes today. We're going to be looking at this P equals mv equation. Okay, so first of all, let's talk about what momentum is. It's how hard it is to stop an object that is moving. Okay, and it kind of goes back to what these 2 points are talking about. With greater mass, there's greater momentum. Greater velocity, there's greater momentum. So if you think about, let's imagine we have a string tied down here, okay? And on the bottom of one string is a 12-pound bowling ball, okay? We have another string, and on the bottom of that one is a soccer ball, okay? Now, if I stand here and you're standing in front of me and I push that bowling ball at you, and then I push that soccer ball at you, which one is going to be harder for you to stop? Bowling ball, why? Because it's heavier. Okay, that's exactly right. Now, let's just pretend we have this soccer ball. Okay? So I have this soccer ball hanging on the string, you're at the other end of this table, and I just poke it. Is it going to be easy for you to catch it?
No.
If I just poke that soccer ball?
No.
Okay? Now, if I have that soccer ball and I punch it at you, is that going to be harder to stop than you poking it?
No.
Okay? It should be, because it's going to come at you faster. Right?
Yeah.
So, velocity and mass determine momentum. The bowling ball is harder to stop. Something coming at you faster is harder to stop than something coming at you slower. Okay? We are going to do calculations that calculate momentum. Okay? In science, variables can get a little bit tricky because we have so many ways that we write things and we put them in shorthand. So this P doesn't really make sense, but that is the variable for momentum. Okay, momentum is symbolized by a lowercase p. Alright? And then momentum equals mass times velocity. So m times v gives us momentum. We have our fancy triangle here that we like to use. Let's go calculate some problems. Okay, let's figure out what this is about. One thing to note before we do that is that our unit for momentum is kilograms times meters per second. Okay, have y'all ever seen that dot represented like a multiplication sign before? Okay, sometimes we do that in math. It's the same thing. This unit looks kind of funky. That's our unit for momentum. Okay? So, let's see what this is going to look like. Example 1. Find the momentum of a zombie running at 3.4 meters per second and a mass of 82 kilograms. Let's plug in those numbers and see what we got. Okay? What variable is 3.4 meters per second?
P. Velocity.
Velocity. Okay, meters per second is velocity. So our V equals 3.4 because meters per second is always velocity. What about 82 kilograms?
P.
Mass. Kilograms by itself is always going to be mass. Okay, so our M equals 82. That means that I am missing P. I am missing momentum. Now looking at my triangle, or even looking at my P equals mv equation, what math are you going to do to find P?
Multiply.
Multiply. Okay, because M and V are right beside each other, we multiply. So P equals M times V. So for us, that's going to be 82 times 3.4. Alright, so I plug those in, and I get 278.8. I cannot forget units, okay? I'm looking for P, so it's going to be that weird looking unit, okay? It's going to be kilograms times, which is represented by that dot, meters per second. So that would be my final answer, 278.8 kilograms times meters per second. Okay? These ones I feel like we're used to and we're comfortable with because of that triangle we keep using. We just got to remember what letters go where. Y'all agree?
No.
That's because you don't pay attention.
Oh, God. That's pretty fun. You do.
You're paying attention today. You don't pay attention beforehand. Or we used the triangle before.
Oh, no, I know.
Okay, good. moving on to example 2. Find the momentum of your zombie teacher as he chases you at 5.4 meters per second and has a mass of 65 kilograms. Which variable is 5.4 meters per second? Velocity. Meters per second is always going to be velocity. Anytime you see that right there. So V equals 5.4. Where are you going to put 65? Mass. Kilograms is always mass. So 65 is going to be your M. Once again, looking for P. Tyler, don't answer this. Johnny, Aiden, don't answer this. What are we going to do to find P? Yep. Don't answer, I said. Multiply. Oh, I thought you did. What did you get? What did you do in your calculator? Multiply? Good. Okay, so P equals M times V. So run this one, 65 times 5.4. And you should get
152.5.
no.
351.
351 is what I got. I don't know what you typed in your calculator.
Oh, I thought 50.
So it should be 351. And we're looking for P, which is momentum, that weird unit. Okay? So 351 kg times meters per second. You with me? Good. Okay, this is all calculating momentum. Now, these first two examples, we were missing P. Okay, this next example we're going to do, we're not going to be missing P, we're going to be missing something else. Okay? So let's figure out how we're going to handle that situation. What is the mass of a zombie that has a momentum of 850 kilograms times meters per second and a velocity of 9.8 meters per second? Okay, what variable does this unit go with? P. Yep. Momentum. You're right. It is momentum, but it's symbolized by a P. Okay, so that 850 is going to go with P equals. What variable is the unit meters per second?
V.
Velocity. So V equals 9.8. Okay, I'm going to draw the triangle. You don't have to because it's on your paper. Alright, but if you want to, you can. So my P equals MV triangle has P on top and then M and V. I'm looking for M, so that's what I cover up in my triangle. Okay, so M is going to equal P over V, just like what my triangle looks like. Okay, M is going to equal P over V. So we are going to divide. You are correct.
I got 86.72.
Good, I think that's what you should get.
Yeah.
Make sure you always put P on top, so 850 divided by 9.8.
I was looking around that. 86.7.
Yep. When you divide those, you get 86.7, somewhere around there, hopefully. I'm looking for mass, so my unit is going to be kg, yes. I heard somebody say that. Alright, I'm going to give you 1 minute to do example 4 by yourself. Do example 4 by yourself. Ready, go. Lovey and Addison, do example 4 by yourself. Okay, I'm gonna ask questions. Make sure you're listening so you answer what I'm asking for. Okay, so hopefully you've had a little bit of time to look at the example 4. Which variable is missing? Velocity, that is correct. Okay, so if you read this, you know that you're missing v. What does p equal?
957.
957.
And
What does m equal?
125 Roman children.
Good job. Okay, next question. Somebody tell me what math you did.
Divided by.
Tell me specifically what you divided.
957.
divided by 1.
Good.
Thank you.
Okay, so 957 divided by 120, because v equals p divided by m. Alright, so I just plugged p divided by m in. What is your answer that you got?
7.9 and a project.
Good job. 7.9, I am looking for v, so my unit is meters per second. Okay, so that's the first half. Simple, hard, medium, simple. Good. Okay, that's awesome. Now, let's get to our second half of our notes today. It's still talking about momentum, and it looks challenging, but it's actually not. So let's figure out how to get through it. We are now going to talk about calculating the conservation of momentum. Okay, so basically what that means is that whatever momentum you started with, that's the same amount of momentum you have to end with. Okay? Conservation of momentum, there's a law about it, and it says the momentum before a collision or explosion is the same as the momentum after. Okay? Classic example of this is playing pool. Alright? Even on your iMessages games, you can see how this works. Or in real life pool, obviously. Okay? So, if this number 7 hits this number 5, what is going to happen to the number 5 ball?
It's going bye-bye.
It's going to move, it's not just going to stand there. Right? Okay? What eventually happens to 7 after it hits it?
It bounces back, like the way it came, or a different direction.
Or slow it down and stuff.
Or slows down and stops. Okay? So, the momentum that this number 7 ball has gets transferred to the number 5 ball. The number 5 rolls off, the number 7 is eventually going to slow down and stop. That is conserving momentum. Okay? There's some math involved with conserving momentum. And like I said, it looks scary, but I promise you it is not. Okay? We're still dealing with P symbolizing momentum. M is always going to be mass. V is always going to be velocity. Okay? If you ever hear me, sometimes I take this equation and I say the M1V1 equation. Okay, I kind of shorten it down a little bit because that is a lot to say. Right? But the main gist of this equation is that the left side of the equal sign is the momentum that those objects had before they collided. Okay? Everything on the right side of the equal sign is the momentum that those objects had after they collided. Okay, and you'll see what I'm talking about as we work through these examples. But all you need to know is M1V1 plus M2V2 equals M1V1 plus M2V2. Okay? And I know it sounds weird right now, but let's just see what that means. Okay? Here's our first example. I'm pretty much going to ignore the words and I'm just going to look at the pictures. Okay? So, as we work through this, the most important part is the first step where you fill in these variables. Okay? If you mix these up, your answer is going to be wrong. Okay? So we got to make sure that we're keeping these things straight. Alright? Left column is going to be before the collision. And I like to put a line through here because this is my first object I'm talking about and my second object I'm talking about. Okay? That's what the 1s and 2s mean. Okay? The 1 is the first object, the 2 is the second object. And I can do the same thing on the other side after they collide as well. Okay? Eventually, the more comfortable you get with this, you're not going to need this line to separate your objects. It's just going to be it gets easier as you do it. So this yellow ball will always be our object 1. Okay? So this is object 1 on both sides. It's still object 1 on this side too after the collision. Alright? So orange ball is always going to be object 2. Before and even after the collision. Okay, so you can see in this picture here, this yellow ball is going to run into this orange ball, and that orange ball eventually is going to start rolling. Okay? Now, let's start plugging in our numbers. So, object 1, what is the mass of object 1? 2. What is velocity of object 1?
4.5.
4.5. It's traveling at 4.5 meters per second. Okay? Before the collision, what is the mass of object 2?
5.06.
5. Yep, I'm just going to shorten it to 5 kg. And what is its velocity? 0, because it is
Not moving.
at rest. Okay? At rest tells us that it has a velocity of 0 meters per second. They collide. Let's get our data of what happened after they collided. Okay? After the bang.
2.
Alright? This is still yellow. It's still object 1. Is the mass still the same?
Yeah.
So M1 after the collision is still going to be 2 kilograms. What is object 1 velocity now? 0. Okay, so V1 on this side equals 0 meters per second. What's the mass of our object 2 after the collision?
5.
5 kilograms. It stayed the same. And we don't know velocity. There's a question mark there. So our job is to figure out the velocity of object 2 after they collided. Okay, I'm going to write down, for this first example, I'm going to write down our M1 V1 equation, and that way you can kind of see how I work through it. Alright, if you don't want to write it down, you don't have to, but I'm going to just to show you some stuff. Alright, so I'll have M1 V1 plus M2 V2 equals M1 V1 plus M2 V2. Okay, left side is before collision. Right side is after. So make sure you're using the right numbers when you go to plug them in. Okay? Now what I like to do, I'm a very visual person, so I have to see it straight up. Whenever I start plugging in these numbers, I put parentheses around the individual ones. Okay? So like M1 is 2, I'm going to put a parentheses around it. What's up? Yeah, go ahead. V1 before the collision is 4.5. I'm going to put parentheses around it. So what mathematically am I eventually going to do with these two numbers? Multiply. Good job. Okay, let's keep plugging in numbers. M2 before is 5. I'm going to put that in its own parentheses. V2 before is 0. It goes in its own parentheses. And then there's my equal sign. Are you all understanding how I'm plugging in these numbers? Okay, if I can get this part right, I can get my equation right. I'm going to leave it as V2. But you can put an X if you want to. Now we're moving after. I have M1 is 2, V1 is 0. M2 is 5, and I don't know V2, so I'm going to leave it as V2. Okay, once I get it set up, that's the hard part. I can start doing that. Okay? What is 2 times 4.5? 9. It's just 9. What's 5 times 0?
0.
I'm going to cross it out. I don't care about zeros. Okay? 5 times 0 is 0. I don't care about it. So next is my equal sign. What's 2 times 0? 0. I don't care about it. So then I'm just left with 5v2. Okay? I'm left with this right here. Are we good so far? Okay, you guys take it step by step. Don't rush through it. Now, how do I get v2 by itself to figure out what it equals? Divide both sides by that 5. Okay? So divide by 5. It's going to cancel out over here. Divide by 5. So I eventually get to where v2 equals 9 divided by 5. Which is, what? 1.8 or 0.18? 1.8. Okay? So my final answer, I did 9 divided by 5 to get 1.8. Okay? I'm looking for a velocity, so what is my unit? Meters per second. Yep. So my final answer would be 1.8 meters per second. Okay. While I erase this, I want you to plug in example 2 numbers. You can try to solve it if you want to as well. I'm going to erase. On example 2, you're going to try to do this part, where you plug in the numbers in the boxes. Okay? When Max comes back, you can. Okay, so right now you're trying to fill in before collision and after collision numbers. Does anybody want to come up here and do it for me? Cool. Okay, Addison's going to see if she can do it. Cool. So far, so good. Good. Yep, do it after you.
This stuff looks really hard, but it's pretty easy. It's weird.
Y'all agree with what you put up there?
Yes.
Me too. You did a good job. Does anybody want to plug in the numbers to the equation? Do all the parentheses stuff for me?
Oh my God, can I do this?
No. Anybody else want to? Yes, Addison, you can do it. You want to do it, Jason? Come on. Come on with it. Let's see how you do this. That's fine. Here. Do this one. You don't have to, don't want to. You've been left-handed this whole time?
Yeah, I've been left-handed since I was born.
Hey, where did
What?
that come from? Look, so, when you have everything on the one.
Yeah, I was like that. Oh, okay.
Got it?
I had it wrong. Okay.
Yeah. See what you can do now. Yep, and that's gonna be 2.5 times 0. The other side is gonna be 3 times 3. Yeah, you got that.
Oh, you should let me solve it.
2.5 times
Yeah, you
300.
should let me solve it.
Oh, I can use 0.0. Good, okay. Now, hold on a second. I'm gonna write it bigger. That way people can see it. Yeah, that's fine. Write it bigger. Good job, Jason.
How are you, man? Did a great job.
Write big.
Oh, well.
Big. Can I do it? Addison did that.
Oh, yeah, never mind.
Here,
Go ahead.
I'm gonna write big and then you can solve it.
Go for it.
Okay, so we have 3 times 5 plus 2.5 times 0, so that people can see it. 3 times 3, and then 2.5 missing variable.
You took the whole space. Come on.
Use a different color.
Wow.
So now we're solving. Yes. Okay, so he also wrote tiny. But, so we multiplied 3 times 5, and he got 15. Okay? Why is there an equal sign here? Like, what happened here? Why did he skip that part? Because it equals 0. Yes. Okay, so he just went straight to the equal sign. We're going to cross that out because it equals 0. Equals 3 times 3 is 9, plus 2.5 times our missing variable. Okay, so far so good there. Is everybody with me on this part?
Yes.
We okay? So that was just doing what the parentheses said. Yes. Okay, now he starts trying to find and get B2 by itself. Okay, what we have to do first is get rid of this 9. Okay, because it's added on to it. So to get rid of it, over here we subtract it on both sides. So minus 9 is 0. Those 9s are going to cancel out. Minus 9 over here is 6. So now we're left with 6 equals 2.5 times B2. Okay, we're getting closer to getting B2 by itself. Alright, so now, in order to get rid of this 2.5 that's attached to B2, we have to divide it off. Okay, so we divide both sides by 2.5. They cancel over here. And then you have B2 equals 6 divided by 2.5. You do that division and you get 2.4. Okay, so our final answer is going to be 2.4 meters per second. Okay, cross out the last 2 examples. Those aren't necessary. If you want to do them, you can. Okay, we have 7 minutes. What I need you to do now is today's exit ticket. Okay, instead of a warm-up, we had an exit ticket. That exit ticket are going to be P equals NV questions. And then you have 2 of the N1, V1 questions. Okay? This gives you an opportunity to do it by yourself. Good to go? Keep your notes. You're going to need them tomorrow in your assignment. Got it?